So hi everyone, welcome to my YouTube channel. In this video I am going to explain you about inverting and non-inverting amplifier using op-amp. So here you can see the apparatus. This is the circuit diagram for both. You can perform inverting as well as non-inverting by making the connections of the input terminals. So here is the voltmeter. You can measure the output voltage corresponding to the applied input voltage. Here the voltage controller, you can apply the voltage of about 0 to 12 volt. And here are the different values of resistors. So for input connections we have to use the resistors, and for feedback resistance also. So let us make the connection for first inverting operational amplifier. And first of all you should know the op-amp, which has 8 leg pins. So here we have the 8 terminals. 2 and 3 are the input terminals. So minus, negative sign indicates inverting terminal, and plus sign indicates non-inverting terminal. And 6 is the output. 7 and 4 we have to connect the DC regulated power supply, and output should be measured across this voltmeter, and input voltage we have to apply from these two terminals. So let us make the connection. Use the given patch cords to make the connection for inverting as well as non-inverting. So this is the circuit diagram for inverting operational amplifier. Let us make the connections according to this given diagram. First of all, we should know what is operational amplifier. So operational amplifier is an amplifier which has high open loop gain, very high input impedance, very low output impedance, and large bandwidth. It can be connected as we know in two ways, inverting and non-inverting terminals. According to the given diagram, first I am making the connections to the input terminals here. So this voltage controller we have to connect using patch cords here. So I am connecting this DC power supply voltage to the 1 k ohm resistance, and then we have to connect this negative terminal of this input voltage to the negative terminal of this voltmeter. Okay, next this connection is completed. We can go for the resistance input terminals. So this is going to be connected to 5 k ohm. So here we have to connect the resistance R3 to this 5 k ohm. Okay, next we have to connect this one more R1 inverting terminal to the 1 k ohm. Okay, next we have to connect this 1 k ohm, the common connection. Next we have to connect this 1 k ohm. So next we have to connect this 1 k ohm to the input terminal. So here we have to connect 1 k ohm feedback resistance network. We have to complete here. So we have connected this, and the output. So output we have to connect this terminal to the voltmeter, and this common terminal must be connected to the output terminal. So this is the connection for inverting operational amplifier, so according to the given diagram. So let us switch on the device. So we can see here the output voltage corresponding to the applied input voltage. So the output voltage is negative here. Why? Because we have made the connections for inverting operational amplifier. So output is always or the gain, if we say, that is negative, because here the feedback resistance is how much? 1 k ohm, and the input resistance across the inverting terminal is also 1 k ohm. So the output must be 1. If we use the formula, we can calculate here. So for inverting operational amplifier, we hereby applied the positive signal and observed the output which is negative. In this formula, if we put output by input voltage, that is minus 1 volt to the plus 1 volt, that is also equal to minus 1. That means this equation is going to be correct. Output voltage to the input voltage equal to the ratio of feedback resistance to the input resistance, which are having the value negative.